Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing exponential functions. This is standard A.9C in the great state of Texas, and we are using item number 28 off the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a toy here that is made up of these cylindrical rings. And as we can see here, the diameter is getting smaller as you're moving from the base up to ring 7 here. And it's 87% of the diameter of the base below it. So really what it's doing, they've already kind of done the hard work for us. Typically in problems like this, they might say decreasing 13%. That's another way to look at it. So if that were the case, right, we would have to take the 100%, we have to subtract that 13% to get down to that 87%, but they already did that for us. And so for ring 2 through 7, the diameter of each ring is still that 87%, and then the diameter base is 5, and we need to find a function. Okay, well, what do we know about exponential functions here? Well, let's go to our standard form here. So y equals a times b to the x power. And so it's going to look something like this. So that means we could, let me take a look at this. We can automatically say g is out, j is out, because they don't have any exponents, right? You at least have an r right there in f and h. But you are needing, this is an exponential problem, so we are needing an exponent. So this a, what do we know about this a? Well, this a goes by many things. So if we're dealing with compound interest, we'll call it our principal, right? Another way to think of it is your starting amount. So what is the amount you're starting with in regards to, principal, or if it's, sometimes we use this for growth of populations, bacterial growth, and they'll say that, there were 18 bacteria, right? You always need a starting point. Or if we're just looking at a pure graph, right, we would say this could be the y-intercept, because the y-intercept is where it crosses the axis when x equals 0. And if this x right here equals 0, right, that means that b just becomes 1. And because, b to the 0 is just going to be 1, so all we're left with is just that a. So this a can be many things here. We are going to use this one right here, this starting amount. This b here is going to be our rate, okay? And so it can either be a growth rate or a decay rate. But what is happening to our starting amount? Is it getting bigger or is it getting smaller? At what rate, right? It is a function, so it's going to have a constant rate. And in this case, we do have a decay rate because it's 87, since it's less than 1, right? If it's less than 1, it's going to be a decay rate. If it's greater than 1, it's going to be a growth rate. That's how we figure it out. And then this b is going to be our, typically it's going to be our time, but sometimes it's just going to be our steps, right? So we just have steps 1, 2, 3, 4, 5, 6, 7 here. Well, what is our starting amount on this particular problem? Well, they give it to us. They say the base is 5 inches. All right, so we can say, instead of y, we'll say d of r equals, and then this a, so a is going to equal 5, okay? And then we need our rate. Well, they give it to us. The growth rate, it's a decay rate of 87%, so we need to turn that into a decimal. So 0.87, and then your steps, instead of that x, it's simply going to be r, since it is d of r. Our answer here is f.